Hello everyone. In this video, we will learn how to perform power law or gamma transformation using the MATLAB, which is an essential image enhancement technique in digital image processing. This transformation, it helps in controlling the brightness and contrast of an image using the gamma value, making it extremely useful for photographic correction, display adjustment, and medical image enhancement. So here the power law transformation, it has a basic form of S is equal to C into R raised to gamma. So here R is equal to input pixel intensity, S is the output pixel intensity, and gamma is the exponent that controls the brightness, and C is the scaling constant. Now these will be the values of gamma. If the value of gamma is less than 1, then the image will be brightened. That is, it will brighten the image and enhances the details in the dark regions. If it is equal to 1, there will be no change. That is, there will be no effect on the image and the output will be same as that of the input. If gamma is greater than 1, then it will darken the image, and that is useful to reduce the brightness. So usually we will change the values as like gamma should be less than 1 or gamma should be greater than 1, because when gamma is equal to 1, there is no effect on the image. Now what does the power law or the gamma transformation does? So it will adjust the brightness of an image by raising each pixel value to a power of gamma. Now how do we apply this in the MATLAB is, we will read the image, then we'll convert it to the grayscale, then we'll convert it to double precision and apply the transformation. That is this formula, that is S is equal to C into R raised to gamma. That is, here for S we are using the variable as gamma underscore image img, that is equal to C, which is nothing but the scaling factor, into image double raised to gamma. So next we will display the original image and the transformed images. Now what is this gamma value? Gamma is nothing but it controls the transformation strength. If it is less than 1, then it will brighten the image, while values greater than 1 will darken the image. This is the flow of the program. First you have to read the input. You have to check whether the input image, it is a color image or it is a grayscale image. If it is a color image, you need to convert it to grayscale. If it is a grayscale image, then you can use the same. And next step is, once the checking of the color image is done, then you have to convert it to double precision. After that, you need to apply the power law transformation and you need to display the original image and the gamma transformed images. Now coming to the program, we'll start our program with the 3 basic commands, that is CLC, clear and close all. As you all know, CLC clears the command window, so the output is easier to read. And the clear removes all the variables from the workspace and it will prevent the old variables from interfering. And close all, it will closes any open figure windows, so the script starts with the fresh figures. Next we'll start our program, main program. So here like first we'll read the image, that is img is equal to im read, and here I've given a path for my image. You can copy your own path for your image here. Once the image is read, then we'll check whether the given image is colored or whether it is black and white, that is whether it is gray. Okay, not black and white, whether it is gray image. So for that we are using the command size of img comma 3, that is equal to 3. That is this size img comma 3, it will check the number of color channels. Here if it is equal to 3 means it is a RGB color, and if the color is RGB, if it is a color image, then you need to convert it to grayscale. For that we are using the command RGB to gray. Okay, this command we are using. So next, if it is already a grayscale image, then it will display the image as grayscale image. Okay, here we are checking in this part of the program, we are checking whether the given image is a RGB or grayscale image. If it is RGB, we are converting it to RGB, or else the same image will be considered as the grayscale image. Next, what we'll do is here we'll convert this to the double precision, and it will scale it to 0 and 0 to 1. So this conversion is done for mathematical operations, and here img underscore double is equal to im2 double img of gray. So here we are using this as the variable, and this im2 double, it converts the image array to double precision, and it will scale the pixel values to the range 0 to 1. Okay, and here this is very important because the power law or gamma operation, it expects the normalized values. Next, we need to apply the power law gamma transformation. So here we are taking the value of gamma as 0.5 and the value of C as 1, and we will apply the gamma transformation. That is the formula, S is equal to C into R raised to gamma. So gamma underscore image is equal to C into img double raised to gamma. Okay, so now here next, now what we have given, the value of gamma is less than 1, so it must brighten the image, and here and the mapping, it is up to the concave up. Next, what we have to do is we have to display the original and the transformed images. So for that we are using this part of the code here. Now here the figure, it creates a new figure window, and subplot 1 comma 2 comma 1, it splits the figure into one row, 2 columns, and activates the first cell. Okay, it will activate the first cell. Next, I am show img underscore gray, it will show the original grayscale image, and title original image. So here this is it will label the subplot. Okay, and this is the second cell. This is for the second cell, to activate the second cell, where we will place our gamma transformed image. Okay, so uh, here title gamma transformed image, gamma is equal to num2 string gamma. So here this will construct a title string that includes the numeric gamma value. Okay, so here it will include the numeric gamma value. Now when you execute this program, we will get the output as like this. So this is the original image. Okay, that is the image which we have given, and this is the gamma transformed image. So actually when executing the program, I have given a colored image here that is being converted to the grayscale image, and for grayscale image we have used the title as original image here. So it is displaying it as original image, and here I have used gamma transformed image. This, see here I have taken the value as gamma is equal to 1.2. Therefore this image has been darkened. Okay, because the value of gamma is greater than 1, so it has been darkened. If it is less than 1, it will be brightened. Now this was for one value of gamma. Suppose if you want to check simultaneously for different values of gamma, then we have some another program here. So here again we'll start with the same three basic commands here. Then we'll read the input, and then we'll check for the image, whether it is a colored image or it is a grayscale image. Once that is done, what we'll do next step is, again we have to convert the image to double. So here it will convert the image pixel values from 0 to 255 to double. Okay, that is unsigned integer to double. Then gamma transformation, it requires normalized values in the range 0 to 1. Next, what we are doing here, we are giving gamma values, 3 gamma values we are giving. In the previous program we have given only 1 gamma value. Okay, and next we need to plot the images. So for that, here we are using one cell for the original image and 3 cells for the converted or the transformed image. Okay, so this subplot 2 comma 2, here it is for two windows, sorry, two rows, and two rows and two columns, and it is in the, and it is activating the first cell. Okay, so here what we'll do, here the first image, that is our grayscale image, original image, will be displayed in the first cell. Next is now we want to do it for three values of gamma. Okay, so for that we have to use a for loop. So here this loop, it is for applying the gamma transformations. First, for the first loop, it will take gamma value as 0.2, then 0.5, then 0.8. So this loop, it will iterate over the gamma values of these three values, that is 0.2, 0.5 and 0.8. So again here we are using c is equal to 1. Okay, and here this subplot, remaining everything is same here. Okay, for I is equal to 1 is to length of gamma values, then gamma is equal to gamma underscore values, c is equal to 1. Here we are giving what, how many values, three values. Okay, next c is equal to 1 only we are taking, then here we are applying the power law transformation, and next we want to subplot these three images. Okay, that is for these three values. For that we are using subplot 2 comma 2 comma I plus 1. So this, it will place each gamma transformed image in the grid. Okay, and next I am show gamma underscore image. So here this will display the transformed image, and title gamma num to string gamma, this will show which gamma value was used. Okay, because we are using three gamma values, and the title will be according to the gamma values here. So when you execute this, you will see three versions of the image with different brightness or contrast depending upon the gamma. So here you will see such type of images. Now you can see here original image is this, that is we have converted our colored image to the grayscale image, and that we are giving it as original image. When I'm taking gamma is equal to 0.2, this image, it has been brightened up. Okay, and when it is gamma is 0.5, so you can compare these two. So when you see this, this is very, like, it is very light image, it is brightening too much, but here this brightening up, it is less here. Again, when you change the value from 0.5 to 0.8, again it has become somewhat darker. When you change it to greater than 1, it will become more darker, as you have seen here. Okay, so here we have taken this image has been darkened more as the gamma value is 1.2. So this is how you do the power law transformation in MATLAB. Now we will execute the program and see. This is for another image of butterfly. So here, sorry, this is the first program with only one gamma value. I will paste it here and we'll run it. So here you can see gamma transformed image for gamma is equal to 0.5. Okay, here we have taken in this program, here we have taken gamma is equal to 0.5. I will change this to 1.5 and we'll see what we'll get. Now run. See, the image has darkened here because the value of gamma, it has been changed for it has been changed from 0.5 to 1.5 here. Okay, now we'll see the second program where it is for different values of gamma. So here let me copy this. Now run this. See, this is for different values of gamma. So first is the original image, Then second, for gamma is equal to 0.2, 0.5 and 0.8. So this is how you convert, this is how you do the power law transformation. That is, this program, it will read an image, it will convert it to grayscale, then it will normalize it, and it and applies gamma transformation for different gamma values. It then displays the original and the gamma corrected images in a 2x2 subplot for easy comparison. I hope you all have enjoyed the video. Thank you.